So today I'm talking about event-driven architectures with Apache Geode and Spring integration. So let me start my timer so I don't run over. All right, so I'm going to go through a brief overview of Apache Geode for those that might not know what Apache Geode is, and also Spring integration, doing an overview of both of those. And then learn out how we can integrate those two to give us excellent solutions that can work well for both of those products, right? How to get your caching layer and Spring integration to work well. And a little demo, and then we'll see what we have for Q&A, okay? And if you have any questions afterwards, spot me out there, just hit me up and I'll be happy to answer any questions. Oh, it's not going forward. Okay, so what is Apache Geode? Well, it's a memory-biased key value store, right? So it also can be queried. So not only the values are stored there, you can actually go off and query it. The name of the query language that it uses is something called OQL, and that's because your values will end up being objects, right? So it has a nice query language that you can go off and do that. And I think I have an example later on what it looks like. It's built to scale. So like if I need to handle more throughput, more load, more transactions per second, I just throw another node on there. Likewise, to scale down, just kill it, right? You can scale down very easily. So you can easily store anything from megabytes to terabytes of data in there, right? So definitely a good caching product out there to go take a look at. Why in memory, right? So, there is definitely a performance difference between disk and RAM. So memory is still valid out there, even if with these really nice SSDs that you have out there. If we kind of take a Grace Hopper reference here, she kind of said, hey, how fast does the speed of light travel in a millisecond or a nanosecond? It's about 12 inches, right, or 11.76. So you can almost walk a mile, I can walk a mile in about 20 minutes. That's how much it would take me to write to memory. If I'm writing to that same amount of memory to SSD, that's about 5 hours. And if I'm writing to a spinning hard drive, a couple days, right? So, if you kind of just think about it from a scale perspective, memory is still important in an architecture, right? Being able to cache things closer to your applications. Okay, so those are some good numbers out there. And it's not real numbers, it's just some made up numbers, but it gives us an reference for when we're out there going off and doing things. Okay. All right, so how does Geode work, right? Well, the API itself, I mentioned it was a key value store. It just puts and gets, right? So it puts key value, and that's the main heart of everything. So if I want to go off and get a customer or get my, some value out of there, you just go off and retrieve it. Very simple, right? It's how to integrate it with your applications pretty easily. Also, that's the main concept of storage inside of Geode. It implements a concurrent map, right? So I could just, if I was using Spring, I could just inject my concurrent map and bam, I'm using Apache Geode. Okay. Spring Data Geode, I also mention that out there as a project. It works really well for Spring integration. Here's an example of what I have to do to get it to this kind of artificial REST interface here, how to get it to do some caching with Apache Geode. I just kind of put that top layer up there that enable caching defined regions. That's how I went off and am using Apache Geode. So Spring makes this real easy. The other thing that you can get on it, with any action where I did a put, I can get events out of it. So it's change data capture, really simple out there for getting, putting Geode in the middle of your active architectures, right? So I mentioned something about this is what a query looks like inside of Apache Geode. I can actually set up what they call a continuous query, where I can set up a Spring Cloud data flow that maybe is over there receiving events. It's a source, right? I have some other Spring Boot app doing some changes, doing some puts. I can actually have a Spring Cloud data flow, or maybe even just some Spring Boot with the Spring integration sitting there, receiving events off of the Apache Geode. The other thing is that I can put it in process, right? So I can actually deploy things to the grid, code, my source code to the grid, and have it be deployed inside the system, right? So now I'm no longer crossing the network boundary to go do some kind of enrichment pipeline. I'm deploying it to that grid and actually getting things there. And I'll have a nice picture where it shows you that in action. So that way we don't have to imagine too hard. Right. Oh, there's a nice picture. I don't know why that did that. Okay. Another concept that is that Apache Geode has is that has this concept of a group. And what that allows us to do is I can take and scale concepts, like so a front office, right? Maybe I have some kind of ability to scale that differently or reason to scale that differently, but it's all part of the same grid. So if you can kind of think of it as a pipeline, right? If I think about Spring integration pipelines, I can scale one pipeline versus another pipeline versus the whole grid. So I can have different pipelines in the background. The demo I'm going to do is very basic, so it's not going to be too crazy because I didn't want to lose anybody. But when we start getting into advanced use cases, that's how you would end up saying, I have one concern coming in, I'm enriching, switching it over to another concern, partitioning and routing on another, and how do I scale up to handle extreme throughput? All right, so let's get into a brief overview of Spring integration, just in case. Patterns book, right? So this is the book on where Spring integration came from, right? It's a great book to go off and go read, or if you are a Spring integration person, you probably already have this on your shelf. Current version of it is up 5.8. I think they just made a GA release just for SpringOne here, so just go off and get that current version. That's what I'm using in this example. All right, so a core concept inside there is something called a message. And just having a message-based architecture allows me to decouple my actors in my logic, right? So one concept or one source, and then how do I separate it from the destination or the other actor in there? So the message, all I have to really know about is the header, and that's where I might put some metadata about my payload. That's kind of what I use it for the headers. Another core concept is a channel, and that's the separation between the two actors in a Spring integration flow, right? You just have a channel. If you think about it as a queue, like a Rabbit or a Kafka, but inside of Spring integration, which that's what I'm going to be using because I want to keep things in memory space. I'm going to talk a little bit about that and why I want to do that. But message channel is like an in-memory concept of a externalized message bus. And I can just keep on chaining those message buses up so that way I can have many steps in there. So that way I have a reusable architecture. I have a componentized architecture that knows how to take advantage of just its small little window of opportunity. So because of all that, it's very patternable, right? So Spring offers a ton of good things out there for us, right? So message routers, so I can route off those keys, right? Those things I stick in the header, I can route off of them. I can split up, say if I put a collection in my message, I can go off and split it up into its, basically go through an iterator and spit out all those objects that are in that collection. And likewise have an aggregator. You can go off and read the books and draw your own, get more information on each one of those, so I won't go through every single one of them. The main one that I'm going to go off and use is, a lot of people have been talking to me about, where is it? Oh, I didn't even put it up there, sync points. I'll at least put Geode up there so it can be a source and a sync. In this example, I'm actually going to use S3. So the Spring community already wrote an awesome S3 adapter. So you can hook up Geode to S3. So I'm going to use a pipeline that hooks us up there. And so let's go off and take a look at that. So let's integrate these things, right? So let's take those two concepts and put them together and see what that looks like. And I'm going to be focusing on the servers, right? So the idea here is I've worked with a lot of customers that have wanted to do extreme throughput, right? So crossing a network boundary is quite expensive. So I am going to be concentrating on the servers and how to teach you on how to get, take advantage of that as well using Spring integration. Oh, there's that animation that I cut and pasted. Okay, so how are we going to get there? Remember I showed you that thing and talked about disk drives? Well, I just didn't want to hit up that network again, right? And that's the cost of the network. It's quite expensive to go hit that network. If you kind of like thinking about making a large Spring Cloud data flow and it's got many pipes and processors in there, you can think of each one of those as a network hop, right? I wanted to maybe reduce that network hop with what I'm talking about here, allowing me to put the data really close to where the actual Spring integration flow is actually happening. So here's another picture of it, right? So if I was doing a little Spring Boot application, hitting a Gemfire is my resource pool, right? So this is just an enricher from a Spring integration concept. It's hitting over here. For every single one of those, I'm traversing the network, right? So that's an added latency on top of it. If I'm in process, there is no network traversal, no round trip time to go get the data, go bring it back, so you can get the throughput. If we kind of just add this up, what is that rate limiting me to? Somewhere around 200 events per second. Down here, we're not rate limited by that. We're just rate limited by what my compute can do, right? All right, so let me talk about a little bit about what the power of this will eventually get to. Is I'm sending in information, right? So I'm doing puts from my Spring Boot application, right? So I'm sending in hey, I got an event on Charlie. Maybe it's my cell phone's pinging or something like that. I'm sending some Twitter. I'm sending it out there. I can go off into, say, some Spring Boot application, go back and reach in that, hey, I like motorcycles, and then come back with that information, or I can just be in here and be like, oh, I got that. That's what I'm talking about, being able to enrich that data inside that process space to get that extra bit of throughput. Let's take a look at the next one. Here's a real-world example of a Spring integration pipeline that I made for a company that would sell advertising, right? So it was geospatial advertising, and basically we would go through and we would get a ping on your phone and comes up and says, all right, I got this GUID, and who is that? Oh, is it Charlie, right? So I go off and enrich with Charlie. I go enrich maybe with some location data. Maybe there's a Wi-Fi router in here that's doing extra location, more granular. So I know I'm in this room versus the cell tower outside. And then basically says, did Charlie opt in? And then I go off and send him an SMS and saying, hey, Starbucks got something, a discount for you, right? So if I added it all up, with this example, it got me down to that 200 events per second that I was thinking about on the other slide. And I couldn't have gotten there if I deployed it outside the system. I had to be in process. And then using Geode's ability to scale out allowed me to hit whatever my throughput was, right? So I was able to process millions of transactions per second. Was it millions? Yes, it was millions of transactions per second just with 4 machines. Right, so it was very low need because I'm doing everything in process. I didn't have to reach out. I didn't have to scale up to hundreds, if not thousands. So how do I actually do this integration, right? How do I get things working together? I wanted to do things asynchronously, right? So asynchronously is better than synchronously for some use cases. For this one, it's going to batch it up for me. So I wanted to send things off in a batch. I could have also done it synchronously, and that would be the other 2 methods, right? We have 2 interfaces in Geode that allows us to do asynchronous or synchronous queuing or pipelines, events. And inside of Geode, there's actually two different kinds of interfaces. One gets called before, if I'm in synchronous mode, before I actually do the storage operation. So if I wanted to do some kind of validation pipeline, I could easily have put it in here. And then if it failed the validation, I could throw an exception. It would allow it to write to Geode. Or I can do it after the fact, right? But it's still in the calling thread. It's still synchronous. So, treat these with kids' gloves. You don't want to put a long duration in the synchronous methods, or else your throughput will be a little bit slower. There, I would say just try to use the asynchronous. Okay, so how do I normally set up a Geode message? I like to put the keys in the headers, so that way I can call off on routers if I need to route it off to different processing queues. I can easily do that. And then the values just go in the payload. Or I can put them both there, right? It's up to you as the architect on what's the best practice, but I like sticking the keys up in the headers, so that way I can use routers, and then I can set up TCP or Rabbit to go, hey, I need this to go off to a Rabbit, to some other processing system, or off to Kafka, or off to S3 in this example. So let's go through a little bit of code. Let's see this in action, right? So this is the part that I had to write for Geode. Basically, I went off and instantiated a Spring context. I used annotations. The source code's actually out on GitHub, and I'll show you the URL at the end. And I went off and got the message channel and injected it in, so that way I can send my messages off to Spring integration. That's all I had to really do from a a Geode perspective. Okay. Where did the pipeline look in Spring? Okay, I omitted all the extra annotations for how to configure the S3 bucket, but you can go look on the GitHub later on. But I set up a stage where I transform that list of asynchronous events. So those are the things that are coming out of Geode saying, what action was it? Was it a create? Was it an update? Was it a delete? And the key and value. And then I'm basically calling, hey, give me a translation into JSON, right? So I'm basically taking that list and just calling, to JSON on it. The S3 message handler didn't like strings, so I gave it bytes. So I had another transformer in there just to do that for me. So it took that JSON string and put it in bytes. And then I said, all right, go send it off to S3. Super simple example. Where would I have done something a little bit differently if I wanted to do that use case where I was doing that message enrichment? Is I would just do a get and then change the body of the object and enrich it with the data that I got off of the get. So it's not too far of a stretch, hopefully. All right, so demo. Let me talk a little bit about the demo before I get into it. Like I said, I'm going to be using what they call in Geode single hop, and what that's doing, it's going to route the right actors to the right machines, right? So it's going to basically partition the workload across several machines. And inside of each one of the machines, I've set up a Spring integration flow on every single box. And they're all the same. And at the end of it, it basically sends it out to S3. And I've configured it to go every 1,000 items, or whatever we had in a second, right? So this is a common use case for people to say back up whatever you had coming out of your cache, or getting it out to your enterprise. The configuration, I just wanted to go through that just because there was a lot to it. How did I create the queue in Geode? I figure I'd at least show you some good stuff. So this is my class name that I had showed up earlier. I can actually tell it which bucket to go through in S3, so I can add in some parameters that I can configure at runtime. So like if I wanted to go to West, the EU, Singapore, whatever it is, I can set that up. The size of my batch, so how many milliseconds before each batch gets fired, and the batch size. So I can easily set this down to 1. I can make it go faster, I can make it go slower, whatever the concern is, I can do that. Parallel, that means I want it to run it on all machines. Dispatcher threads, that says how many threads of execution did I want to run on every single machine, right? So how much more throughput do I want to get in there? I think by default it's 5, but I didn't want to have everything get crazy. I'm running it on my laptop here. Persistent said, hey, I might as well turn it on just so that way when you go back and look at it later on, you're like, how do I do this for my really important data? Well, for a throwaway use case, I wouldn't have put persistence in there, but I put it in here just to make sure that we can use it later on. And then I want to order things by key. So that would be everything about Charlie goes out through one queue. So if I make multiple changes of it on Charlie, it's all going to go out the same queue. And then I said, hey, if I did have multiple things in one batch, only send out the last one. Okay, so let's go ahead and run through the demo. Just want to make sure I'm not running anything. That's fine. So I always like to make little scripts that go off and start up everything. So this is going to start up two concepts. It's in Geode, it has like a locator, which is a registry where everything can find everything. So if I start up my servers, they go off and register themselves with the locators. So that way when a client comes online, they don't have to know about how many servers are in the grid, right? Is it 3, is it 600, right? I only have to know about a subset of the locators, and then that's good enough. So for this example, I've set up 3 servers and that one locator, right? Just for examples, right? And then because I knew I wasn't going to be able to type properly and quickly, I made a script to go off and configure it, which runs that command that I showed earlier, the creating the async event queue, and then create a region, right? And I said that it's partitioned, so it's on all the 3 machines, and they're all going to do an equal amount of work. Okay. Let's go to my IntelliJ and go ahead and run that. Okay. Oh, I should have showed you what was in S3 beforehand. And I had stuff there already because I was testing it earlier. But I'll hit refresh and more things show up, right? So you can get the idea that, hey, there used to be last on my last refresh. Here, I'll just delete it and rerun it again. Because it basically only takes a second for it to pop it up there. And then I'll hit refresh. And we can see that there was nothing there. And I'll go ahead and hit play again on that example. So it's going to go through, it's going to do 2 for loops of 100 iterations of 100 iterations because I wanted to do put alls, and that's like our batch operation in Geode. So that way I get our fastest throughput. And I just made up users, right? It was just totally random users, and I just injected them in there. All right, so now if I go back to my S3 browser here, which I'm using CyberDuck, there's my subdirectory for the example. Hit refresh, and I put a time on it, and then this is all the JSON documents coming out of it, and if we wanted to take a quick look at them, let's hit refresh. There it goes. Edit, and make it bigger. So this is just the JSON version of whatever I put in there from an object from jQuery. So that went from my client driver. I did a bunch of put alls in there, went through and did a storage operation, so they're actually persisted as well in Geode, and then also wrote out to S3, so that way I, for whatever reason I picked that, but it would be easier to think of it conceptually as maybe writing out to Kafka, but I liked S3 because somebody asked me to do S3. All right. So I think we're getting pretty close on time. So let's go back to the presentation. So in summary, I mean, we Showed you some general performance concerns, right? The numbers everybody should know. That's a good thing to go off and look for, people that are doing performance applications or even just your regular applications. And you're saying, all right, how do I go off and make trades on disk versus SSDs, right? It's a great little website just to kind of get an idea for, hey, what's that network hop costing me? We saw what Geode is. We got a brief overview of that and Spring integration. And then we saw the little demo in action. All right, does anybody have any questions? You can take a look at the source. I put in couple links there. I just updated it, put a little README there. I'll probably continue to write the README later, especially based on any questions anybody has. No questions? I should have brought some socks from the Pivotal booth. All right. Okay. Well, if you do have any questions, you're just not, don't want to ask here, I will be available after the meeting. Thanks.
I said a general question.
Oh.
Kind of new to me.
Okay.
Where does it fall? Do I write to it instead of my standard relational database, or do I write to code, or cache, or how does that fit in?
All right, so you were asking about patterns on how to use Apache Geode, right?
Yeah, I don't know. This is nice. I don't know how this fits into how I do my job.
All right, I'm going to bring up a quick slide just because that sounds fun. There's many patterns that you can do with Apache Geode, and I'm just going to bring up this slide just because it shows our actors here. You would write to Geode. There's two patterns. You can do cache aside, right, which is like, hey, is it in the cache? No, it's not. And then my application goes to your database and then goes and puts it in Geode, and then that's good. That would be one usage pattern. That would be like, hey, I'm doing MVP. However, you can make it so that way Geode takes care of that for you. So you separate the concerns, and you can have Geode go off and call your, using the cache loader and cache writer concepts. And it can go off and call those back-end sources, right? So be it a mainframe, be it some REST service, be it an Oracle. The one thing that Geode will do for us is it'll control what they call the stampeding herd, right? So if I have a ton of requests on Charlie, from a picture I'm loading my web page, and I have 12 different panels on my web page, and they're all asking for Charlie. If I have Geode at least doing that for me, we'll only have to look up Charlie once, get it cached, and then all the rest of the requests get satisfied from that. If I did cache aside, some subset will get the cache hit, right? So it's better to have Geode in control of that, if you can. Yeah, you could have it so that way data gets routed in through a given actor, right? And so that way, if I wanted, this had some really cool hard drives on it or some kind of graphics cards, I probably would use those server groups, right? And say, hey, I want to do some really wicked calculation. These are the two machines that had the cool NVIDIA graphics cards, and I wanted to do some calculations here. That one wasn't too good, so we're not going to go there. So I would put a group on there and say, go run this action on those two machines. So it's very common in the banking industry to do that, right? To carve up the machines with special compute versus storage. Mm-hmm. Yeah, yeah. Well,
now the Kafka itself is queuing now, writing the application. This application is also queued.
Well, Apache Geode is a key value store, right? So it was a question about, Kafka, Apache Geode, right? Getting the ideas there. So Apache Geode is a key value store, so it is more like a database, right? So I'm going to store some information there. Would it be a replacement for Kafka? Well, it does have messaging concepts, right? And these are durable queues that are highly available to write out to the backend systems. So it would be like, hey, my application would go off and use this. I can then write to Kafka in the backend to make the enterprise aware of the changes that are going on, and then I can partition the writes out. So I can get a really high throughput, so like maybe hundreds of thousands, if not millions of transactions per second happening on the grid. We're conflating it up, batching it out to Kafka. That would be like a really good use case. It's okay if it's hundreds. You're still saving that in-memory speed for your application, right? Especially when we're talking about web and mobile. Nobody wants to wait for that button click. Excuse me. Question in the back. So Spring Cloud Stream, I would normally say you can make it an external actor. Because I guess I could deploy it there because it is Spring Cloud Stream is like kind of a Spring Boot app, and then you can have your Spring Cloud data flow be the one actor above it. I personally just like going lower, right? Yeah. Yep.
So in some other talks, I've seen them talk about the reactive repositories.
Mhm.
I know you mentioned the continuous query here. Why is there a reason that Geo doesn't have the same sort of library, the reactive repository library access?
Reactive, all right, so I'll talk a little bit about history. So how long has Geode been around? So I've been using Geode since like about 2004. It was just predates some of the concepts of reactive. Could it be participating in a reactive architecture? Yes. Meaning it could be in the repository. If I think about Spring Data Repository, right, I mean, we can kind of make it be an actor in that ability. Does it implement the interface today? No. Could it tomorrow? Probably. Thank you. Any other questions? All right. If you have any that you didn't want to ask, thanks.